Uh, Hello all, welcome to another session of system design. Today we are going to do a mock interview and we have Abhishek as the mock interviewer and Mindpixel as the candidate. So with this, I would like to hand it over to these folks. Over to you, Abhishek and Mindpixel.
Thanks, Asim.
Mindpixel, do you mind telling me the name so that all?
I'm fine if you call Mindpixel.
Okay, that sounds good. Okay. Um, hi, I'm Abhishek, and I'll be your interviewer today. So I just want to briefly give you an overview of what the format will look like. So this interview will be basically for around 55 to 60 minutes. Let's spend first 10 minutes or so getting to know each other. And then I will present you a system design problem, and then you can spend next 45 minutes discussing about it. Okay.
Sure.
Okay, so I'm Abhishek, and I have total 8 years of experience working at various levels of software stack. And most of my experience and interest is in building backend systems involving large-scale data storage, data processing, and data search. So I want to now give you a chance. Can you give a brief introduction about yourself?
Yeah. Hey guys, I have 12 years of work experience, and for my preparation, like I've studied DDIA and AlexU, and basically targeting for L6 level.
Okay.
Yeah.
Sounds good. And like, do you like how much experience do you have working on building backend distributed systems?
I have around 6 to 7 years of work experience in working on these backend system independently. Like my current role is kind of an IC role, and I'm totally into technical things like no people management. And my current role is like I'm taking care of the APIs in my current organization for the Apex level.
Okay, sounds good. Okay, so let's jump into the system design question that I have for you today. So basically, have you ever played this game Pokemon Go?
So you want me to design a game called as Pokemon Go, right?
Yeah.
Cool.
Okay, so just want to know, like, do you have any idea about this game? Have you played this game?
No, I have never played this game.
Okay, so let me give you a brief overview. So basically, users will download this app, Pokemon Go, and then so each location has some Pokemons, and so basically they have to go to that location to collect their Pokemons, right? And so each user has a score of points. So in our case, let's give them 1 point for collecting one Pokemon, right? So I'm basically interested in the backend system behind this Pokemon game, Pokemon Go game, where we are collecting the points for the users, right? And the main focus is on the feature. So that feature is leadership board. So what that feature means is a user, he can select any region in the map. So he will be shown a map, right? And he can zoom in and zoom out of the map. So whatever area the user has selected in the map, it should show me top 5 users for that map, top 5 users who have collected most Pokemon Go's in that area, right? And it should basically refresh as the user zooms in and zooms out.
Sorry, I missed the last part. And refreshes as the user.
Yeah, I mean, as the user will select different region in the map, so it should be dynamic, right? He can maybe select some particular region, but then he can zoom out and select a bigger region, or he can zoom in and then select a smaller portion of region. So it should refresh based on that and show
Right.
me top 5 users for the reason for the region that he sees on his phone.
Sure. So, like a few things I wanted to check out for this one,
Mhm.
right? So, what is like basically the geography? Like, is it for some specific location, or like, users can join in from any location? Like,
Yeah, users can join from any location. Like,
okay. And the maps, like, what is the format of the maps?
the format, so like any map, like if you have used Google Maps, Bing Maps, right? So that kind of a map, he will see that kind of a map in his system.
Mhm. Fine. And what is the volume of users? Like, how many users do we have?
Mhm. So you can say that at a time we have 1 million active users.
Mhm. And how many users can play at a particular time? Like, can there be a possibility that these 1 billion users all can play at a particular time? Like, how many users can be accommodated in a particular map?
So yeah, I mean, 1 million active users of my application, and in a region, like it would be some average of like some users are playing in some region, some users are playing in some region. So you can take average that would be in a particular region.
Okay, so how many regions do we have in total?
So let's start with one particular country. So let's say we are building it for US, and
Mhm.
so like let's see how we do in US. But just keep in mind that if our app becomes very famous, then we would want to go internationally. So we should have ability to scale our application in future. But right now we will see how we do in US.
Sure. That is fine. And then what are the pointers? Like, how do the users get to know where are the coins? Like, they zoom into a particular map.
Mhm.
So in the map itself, they see that, the coins are present in a particular region, or there are any hints or anything of that sort.
Yeah, they will see like whatever map they have selected, they will see what are the Pokemons available in that area, and they
Mhm.
can then they have to physically go to that location and to collect the Pokemon. But basically, again, so the let's focus more on getting the leadership board, and you can assume that these features, like you can just discuss about the basic storage and all, how this kind of information is available, but we don't need to implement all these things. We are mainly first focusing on the
The
leadership board, and
leadership.
then
Sure.
when we have time, then we can go further.
Fine. So the APIs which I can think of it like, for this particular application is assuming that the users are already registered, right?
Mhm.
So we are assuming that component is already built out, like we are not working on that. Or do you want to
Mhm.
take care of the user registration, onboarding the
No, yeah,
users?
it's there. It's there. Yeah, we
Fine,
have existing system.
right. So the APIs which I can think of, like, we'll be exposing is one is to select a map, select a particular region,
Mhm.
right? And in that case, we'll ask the user for their user ID, the auth token.
Mhm.
I think once the user is in our application, so it means he's already authenticated. So I think the user ID is fine. And then we'll also take the region ID,
Mhm.
that on which particular region the user wants to go. Uh, as of now, I think, like, these are the two parameters which are fine.
Mhm.
Then another API can be to collect the Pokemons. So this will accept the user ID, the region ID, that this is the particular user. He's collecting these Pokemon from this region, and the Pokemon count, that how many Pokemons he's collecting from that particular region. So is there a limitation that the user can collect only one Pokemon at a time, or he can collect 5 or 6?
Yeah, let's simplify that. There is one Pokemon count in
Okay.
that particular like kind of latitude, longitude. So yeah, so it's just +1. When he goes there, he gets a +1 in his score.
Sure. So still, like, right now it's 1 + 1, but then for extensibility, let's take it as count. So tomorrow, if you want to extend it, let's say that, simultaneously he can collect more than one, right?
Okay, yeah.
Then another API can be to view the leadership, right? View score. And the scorecard which which a particular user sees, that is based on the region, correct?
Yeah, exactly.
So he gives a particular region and he sees the scorecard present there. Then we'll also have a API for zooming in a particular region. And the percentage by how much the user wants to zoom in, correct?
Yes, so we are using again maps, so they provide all these features. So let's not worry about 4 and 5.
So these are the 3 APIs which I can think of that, that solves our purpose. Like, are you fine with these, or do you think like we need to introduce any other API?
No, these are a good start. Yeah.
Fine. Then I'll just go ahead with the data modeling, just to see, like, what all tables we need to have in our application. So one I can think of is basically the users. Like, for user, we have the user ID, then the current location, like, the latitude and the longitude. And their current score, right, which is attached to their profile. This is basically the user profile. And then another API which I can think of, the table which we need is the regions. So it will be the region ID. I'll have the latitude, longitude. And then I'll have one more table as the Pokemon. I'll have the Pokemon ID. And the score attached to that particular Pokemon. And then a mapping table between the regions and the Pokemon that, in which region, which Pokemon exists, right?
Can you talk more about this table?
So I see that, in a particular region, we can have, say, 5 or 6 Pokemons, right? So that's why I wanted to have this region Pokemon map, wherein I have the ID as the primary key of this table. Then I'll have the region ID. And this particular region ID has what all Pokemons. So I'll have the Pokemon ID, and then I'll even have, the user which collects that Pokemon. So I think That will be based on the current game section, right? Session, sorry.
Mhm.
So do you have any like any doubt with this mapping table?
Yeah, no, it sounds fine. And
Mm-hmm.
I mean, so that we have spent enough time on things that are important for this discussion. So again, I just want to emphasize that you can assume that these kind of things are already in the system, but our main focus is on getting that leadership board, right? So just focus what things you need to build for that. And for others, you can say that we have a system like this. You can give me a brief overview and you can say we have a system like this that does that. Okay.
Fine. So for the leaderboard, like we'll have the ID and then a region ID. That for this particular region ID, who all are the top 5 leaders, correct? And then the user ID.
So ID is, what is the ID?
ID is the primary key of this leaderboard.
So, and how are you going to fill this information? Because like if you consider a map, I believe there are infinite possibilities that you can zoom in and zoom out and select regions, right? In a big area like United States, right? So
Right.
how many of those regions? So what is this ID? Can you give more information about that?
So, I mean, like, when we say we can zoom in and zoom out, so there will be, limit to which we can zoom in, correct? So,
Mhm.
assuming we can zoom in, like, if we talk about the geo hashes, right? So, using that, like, there are 7 to 8 levels to which we can go deep down on into the surface of
Mhm.
Earth, right? So if we zoom in, so I'm like I'm not 100% sure, but then the area that comes out to be that is around 10 by 10
Yeah, we can
piece,
assume
right?
that like I don't need your knowledge on geo and all this. So let's go with assumptions. Okay, so we have like some area. You're saying minimum area that a user can select is maybe 10 miles into 10 miles, right? So
Right, that is
that's
10
why
miles
we
into
have.
10 miles. So that is the region which a user can zoom in, and you know that will tell us that who all are the leaders in this particular region, correct?
Yeah, right, right. Yeah. So I'm saying that, so now the possibilities of those regions, so 10 kilometer into 10 kilometer plus there can be bigger regions, plus like if you shift your map here and there, so it's just slightly away from that, maybe 1 mile away from your previous region, and now it's another rectangular box of 10 kilometer into 10 kilometer. So there are
Right.
so many possibilities possible, right? So how are you going to fill this table? And
So
when are you
I
going to
mean,
do that? Yeah.
we'll take care of the neighbors of that particular region,
Mhm.
right? So if we think about each region as a square, so
Mhm.
there like either we take it as a square or we take it as a hexagon, and
Mhm.
then all the neighbors, like whenever a user zooms out or like he moves around in that map, we'll just take care of those neighbors, right? So the data structure which we want to maintain, I mean, like we can talk about that in the deep dive session, like what kind of data structures we want to maintain so that it is easy for us to traverse through all the neighbors to calculate the
Mhm.
leaderboard, right?
Okay. 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 Sure. Okay. Sounds good. Let's move forward.
Yeah. So, I mean, this is what I have for the data modeling. So let's start with the deep dive,
Mhm.
right?
Okay.
Like, do you have any concerns or anything you want to cover here before moving to the
No.
deep dive?
Yeah. No. It sounds like a good start. Yeah.
Fine. So for the deep dive, you basically want to concentrate towards the leaderboard, correct? So now, before the deep dive, I just wanted to create a high level diagram, like, how things look like, and then we can just start with the deep dive, right? So we have the, there will be a lot of users for our application. So the users will be present, and then we will have the API gateway in front of our system, like which receives all the requests. It basically sees what kind of request the user is sending, like whether it is to see the leaderboard or it is to look into a particular map. Based on that, it routes the request to different services. So we'll have different services like collect Pokemon, service, use scorecard service, and another service will be the map service, right? So whenever a user wants to, he zooms into a region, he collects the Pokemon. In that case, we need to update the values in the database for that particular user. So when he collects a particular Pokemon, we update that particular user that his current score has increased, and along with that, we also update the leaderboard for that particular region, like in case his score is more than the top 5 already present there. So we have this user database. When the user wants to see the scorecard, or he's in that particular region at that time, when we show the scorecard, so even the scorecard will be communicating with the leaderboard database. And then the map service will have all the information of the different regions which we have in our system. So the user sends a request to this API gateway. And then based on the type of request, it routes the request to different services. And there will be a load balancer sitting in front of the services, because if we look at the number of users, the number of requests we are getting, like that is pretty high. So there will be load balancers sitting in front of all of our service to because like multiple instances of the services will be running to route the requests accordingly. And the algorithm, like we can talk about that in the deep dive session. The scorecard service talks to the leaderboard service, and the map service talks to this map database. So this is the high level diagram, like which I can think of based on our APIs. Does this sound fair enough, or you have any corrections?
No, this sounds great. Yes, this sounds a good start.
So now in the deep dive, we want to talk about the leaderboard first. Fine. So how the leaderboard gets generated and how a particular user sees like who are the top leaders in that particular region, correct?
Yes.
Fine. So let's do some estimates. We have 1 million daily active users. So our daily active users are 1 million, and assuming 20% of the daily active users are kind of playing at a particular time, right? 20% of daily active users. So we have 0.2 million, right? 200K concurrent connections, like these many users are currently playing in our application. And while playing, like they are receiving a lot of information what other players are doing. Like it is a two-way communication happening between the users and our servers. So that's why I prefer a WebSocket connection here, right? Because that is kind of a persistent connection, and then the users can pass on the information to our servers, and the servers can also pass on the information to the user, right? So to maintain these 200K simultaneously WebSocket connections, like that is difficult for to be maintained in a single node. So that's why we need to have a lot of nodes to make these connections, right? So so we'll have to make WebSocket connections here. Now we need to decide how do we make it, how do we route the user request? Like we have two options. Either we do it based on the user ID or we do it based on the region ID, correct?
Mhm.
So each server which holds the WebSocket connections, either it can, like we can route the request to the service based on the user ID or the region ID. There are different pros and cons of this approach, assuming we maintain WebSockets based on the user ID, correct?
Mhm.
So in a particular region, say if we have 10 users playing, so there can be a possibility that all those 10 users are residing on different servers, correct? So
Mhm.
suppose one user, he collects a single Pokemon. In that case, we need to send that information to other 9 users who are whose session is maintained on different servers. So it will be kind of a scatter and gather approach, right?
Uh, are you talking about writing the information to basically
I
increase
mean,
their score,
see,
or
it is an interactive game. So in case a user picks up a Pokemon, so that information needs to be passed on to the other users in that same region, correct?
Mhm. So you're
Or
saying when a user, so let me just ask few questions from you. So when the user collects a Pokemon, right, and
Mhm,
someone is also viewing a leaderboard in that area, right?
mhm.
So are you going to update it immediately, or are you assuming that the reads to those updates will take some time?
No, I haven't come to the leaderboard point, updating the leaderboard or anything. But then when
Okay.
we say we have a number of users, so 10 users are there in that particular region. So are the
Mhm.
users able to see each other or they cannot see each other? Are they only seeing the Pokemons present there?
They are only seeing the Pokemons, and they can only see that, so they can see their score whenever they want. But uh, otherwise, they can see the top 5 users in the region they have selected.
Mhm. Okay, so it's kind of if a user selects a Pokemon, we need not share his that information to the other users present. That initially there were 7 Pokemons available. One of the users collects one Pokemon. So now we need not show this information to the other users that only 6 are available. I mean, like, shouldn't it be kind of a real time wherein the user sees that okay, out of 7, one has been picked by someone else. Now only 6 Pokemons are available.
Okay, I got your point. So let's say, let's simplify it here and say that basically the Pokemons are fixed. So it's not like that if someone has taken the Pokemon, others won't be able to take it. Others can also take the Pokemon, uh, and so each user can take that Pokemon
Fine. That's
available.
absolutely fine. Yeah.
Mhm.
So we were on the WebSocket connection that, whether we want to maintain the WebSocket connections based on the user ID or the region ID. So with
Mhm.
the user ID, the issue, which I said was, to fan out the information, but then to make it simple, like we are not fanning out the information. So now if we go ahead with another approach to shard, to route the request based on the region ID in that case. So for a particular region, if we have 10 users, so all the WebSocket connections are maintained on the single machine, correct?
Mhm. Yes.
So even though we are not passing the information, but still we need to show the leaderboard information. So that will be pretty easy for us because we need not, fan out that leaderboard information to 10 different machines. That will be routed to only a single machine and all the users are present there. So it will be easy for us. Moreover, the drawback with routing the keeping all the WebSocket connections based on the region ID is the hotspot issue in case there are a lot of users who are present in that particular region, correct? Because initially we said that we'll be distributing them equally, but then we want to make it scalable, and there can be a possibility that a lot of users are present in that particular region, right? So in that case, what happens is all of the users, if they are in the same region, then the fan out will increase to say 100x or 1000x, and
Mhm.
that will that can become a bottleneck. So to fix that issue, like what we can do is when a particular user comes in, he connects to a particular region. So we can introduce like either suffix or prefix the region ID with 1 digit or 2 digits to increase our range, and that will even increase the randomness, right? Even that will
Can you
involve
tell
us.
me, sorry to interrupt, can you tell me why do we need fan out? So what component are you building right now to that needs fan out?
We are fanning out the leaderboard information, right? Because that is a real-time thing
Okay.
which we need to show to all the users, correct? Even though we are not showing the live information, we want to keep it simple, but still we want to show the leaderboard information to all the users, and the leaderboard information is changing dynamically, right?
Right. Okay. Yeah,
So
got it.
that is
Okay.
the information which we'll be fanning out.
Okay.
So this is how the WebSocket connection is uh, maintained. So I think we'll prefer going ahead with the region ID. Like all the WebSockets are maintained based on the region ID the users are connected to. Then the second point which we want to talk about a leaderboard is like how do we calculate the score, and like do we always hit the database or how that is done, right?
Yeah.
So we saw that the rights were around 200K, like 200K users are simultaneously playing, and assuming right now we have around 50 regions, correct? And each region that can have around
There will not be 50 regions. Again, there will be infinite regions because user can select any map region, right? And he will see the leadership board. So
no, but then initially when we discussed, we said that there will be a 10 miles cross 10 miles region, correct? So when a user
so
selects
10
it,
into 10-mile region, and then now if you like spread it across United States, there could be so many regions, right?
Right. Yeah, that's
So
absolutely
let
fine.
me wait, can you see, like, let me draw here. So let's say this is the map. How do I draw in this? Freehand drawing. Can I do freehand drawing?
Sorry, I have no idea, but then I have given you the right prompts.
Okay. I mean, do you understand
no worries.
Why there could be infinite regions possible, or do you want me to explain it more?
I mean, I do not understand the concept of infinite regions. For me, what I understand is when a user goes into a particular region, that is a 10 miles cross 10 miles. And if instead of if I take it as a square, right, 10 cross 10, so I should only be worried about that particular square and the neighboring squares, correct?
So yeah, you have to give me the score for, so let's say, I don't know if I will. So let's say this is entire United States, right? And so you can see there could be so many 10 kilometers into 10 kilometers region possible. But let's say as a user, if I have selected, and it will be basically square, but let's say if I've selected this area, right? I can select this area, or I can select this area, right? So these two are different because my number of users in that particular region are different, and the users that are in that particular region are different. So you have to show me the score of the users in this particular region. Right? So top users in this region. And so basically, like, just to explain more on the question. So basically, let's say right now, Mindpixel was in Florida, right? He collected Pokemon in Florida, but now he moved to, let's say, Washington, right? So the Pokemon that he captured in Washington will be like his Pokemon collected in Washington. So now you have to show me the top users that have collected maximum Pokemons in that user. So you have to only take the Pokemon that I collected in that area in, let's say, Washington. You don't have to take the Pokemons that I collected in Florida.
Okay. Got it. So when a user moves in from one region to another, then he leaves away his Pokemon in that region only, correct?
Yeah, I mean, then his calculation will be like, let's say I collected 100 Pokemons in Florida and now I moved to Washington. So, and at that time I was the leader, right? So although I have moved, But if someone else have not collected more than 100 Pokemons in Florida, then if someone will see in Florida area who is the top user, I will be the top user because I had collected 100 Pokemons in Florida. But now, since I moved on, if someone has now collected 150, then I will be second most user, and that someone else will be the top user.
Sure. Right. So we were talking about this particular regions that, how do we take care, like whenever a person collects a particular Pokemon, how do we update the leaderboard, right?
Yeah.
So for each region, when you say Florida and Washington, so these all, right? So inside them also, we will be having all these region IDs, correct? A 10 cross 10 mile square, right? So for every square, we will be having a leaderboard. So it all depends upon us. How do we want to scale our system? So we will be getting a lot of streams that, for all the regions, all the 10 cross 10 miles regions, what all users are present there. And we'll be getting a stream of the scores, as in when the user keep on collecting the Pokemons. So we will have, if you think about it, like, with so many squares and so many users, there will be a lot of data which can overwhelm our system to consume directly, right? So when a user collects a Pokemon, we might have to introduce a queue in front of our service so that asynchronously we keep on processing them, right, for that particular regions. So once we get
okay.
Sorry, go ahead.
No, I just want to know from you. So when the user has collected a Pokemon, right? What do you want to do first? What's the first most important thing you want to do?
So when the particular user collects the Pokemon, what we want to do is we want to increment his score, and then we want to, right, and then we want to check whether in that particular region his score beats the other user's score, like, the top 5. If yes, then, we change the leaderboard, correct?
Yes. So, okay. So you talked about two things we need, right? So which component do you think we should do synchronously and which we should do asynchronously? Like, if you're building a game like this, which component do you think should be synchronous and which one asynchronous?
So, like, incrementing the users count should be synchronous, and then fanning it out, like, updating the leaderboard and fanning it out to all the users present in that particular region, that should be asynchronous.
Yeah,
and by asynchronous, I mean like, the user should be able to see that, his score has been updated, say within few milliseconds, but then the new leaderboard that can flow down to the user, say within 500 milliseconds, correct?
Yeah, exactly. I totally agree with you that the user database should be updated synchronously so that once I've collected the Pokemon, I can see my updated score, which is totally consistent. But leadership board, it can take some time to update. So that system can be eventually consistent, right?
Right. But then my point of view of introducing a queue was because, like, we have 200 case users simultaneously playing, and assuming that, each user collects at least 2.2 Pokemons. So, with 400K writes coming into our system, like, it'll just stall our service. So that's why, I said that we might have to introduce a queue so that at least we can start ingesting or so that we can start ingesting all of those events, and then aggregator service can start pulling the data from different topics in the queue, right?
Okay.
And then it is based upon us, like, how we want to aggregate, like, say we are getting a very fast stream of inputs. So there are different strategies which we can apply in our aggregator service, like, it pulls out a batch of those events and see that, these are for which particular users, which particular regions, and accordingly it calculates the score and, update the user score, and along with that the leaderboard. But then every time going into the user database and the leaderboard database, again, that will be a performance hit. It will introduce latency due to the network hops and the database hits. So for that, what we can do is we can introduce a cache in front of them, a write-through cache, in the sense that, we update it directly into the cache, right, instead of going into the database. So this will increase the performance because the cache will be present inside the services, right? So there won't be a network hop, and moreover, since cache is in memory, so it will be pretty fast as compared to a database hit, right?
Yep. Yes.
But with like introducing a cache, that may introduce some complexities in the sense, suppose if you say that the cache goes down, then we just lose all of the data, say the leaderboard and things like that. So in that case, what we can do is we can take regular snapshots of our cache and keep on dumping them, or asynchronously update our database, right? So if with these two approaches, if we take the snapshots, still there can be a case that once we take the snapshot, after say the next snapshot has taken, the cache goes down. So there will be a miss of some time of data. But then since we get a very fast stream of events from the users, so even if we lose, say 500 to 700 milliseconds of data, I think like that should be acceptable, right? Because we anyhow we are saying that it will be eventual consistent for the leaderboard. So we can pull that data from the database, user database, because anyhow the user data like scores are getting updated synchronously. So that is an atomic operation, right?
Okay, so can you talk more about this dropping? That what kind of data will be getting dropped?
The leaderboard data. So we have these two data, like one is the user score and another is the leaderboard, correct? So I said that we'll be keeping all of this information in the cache, because going over the network and then updating the database, that will introduce latency in our system. And since we want to show the data as near as real time to our end users, it's better to introduce a cache so that we prevent a network hop along with the database hit. Now with the cache, there can be a possibility that the whole cache goes down, correct? So for that, I said it's better to take a snapshot of the cache in regular intervals, so that in case the cache goes down, we can again build up that cache from the snapshots. But then there can even be a possibility that the snapshot which we are taking, suppose the snapshot resides on the same machine where the cache is present and the machine gets corrupted. So even, the cache is kind of like, we lose the snapshot, we lose that. So in that case, what we can do is we can, replicate our snapshots in a separate node in some time intervals. Another option can be to asynchronously update the database, right? So with both of the approaches, still there is little chance of losing some of the data points. So I was earlier talking about like, there can be a possibility that you take a snapshot. So between two snapshots, when the cache goes down, we can miss some of the data, right?
Okay. Yeah. So, and basically our requirement is we cannot miss the data, and the latencies also should be very low. So is there some way that we can guarantee that your data will not get lost, and also you will get good performance of the system?
Right. So in that case, like, the snapshot, which I said that the snapshot will be based on some regular intervals, say every 2 seconds. So instead of the snapshot, what we can do is we can introduce a write ahead log, which will be there in on the same node where my cache is present. And whenever I update anything in the cache, I make sure that synchronously I append a statement in the log saying that, this was the particular entry. So this will this is pretty fast. So it won't introduce much latency, and moreover, in case my cache goes down, I still I can still build up my cache and recover the data from the write ahead log, right?
Okay, I got these points. Yeah, let's move ahead. Okay, so we have all these things here, and so now I just want to focus more on this again leaderboard part. So basically, you said synchronously we will update the user database, and asynchronously we will fan out this and update the leaderboard, right? So and I think now you got my point that there could be infinite regions possible, right? So like how will you fan out? Can you give more detail that how will you update the leaderboard? How will you find the points that you want to update and all that information? How will you take care of that?
So, I mean, the granularity of our leaderboard scores like is on that 10 cross 10 mile region, right? So now
Mhm.
whenever a particular user is in that 10 cross 10 miles and he moves to another neighboring region,
Mhm.
right? So in that case, we take care of the region he was present,
But
but
let's
then, like,
say,
we also said that when a particular user moves from one region to another, in that case, the previous points are not considered, correct?
yes. And
We need to
also,
build his score. Sorry, go ahead.
no, I'm saying that if in leaderboard you are storing 10 cross 10 scoring, that for this region of 10 cross 10, this is the leaderboard. But
Mhm.
now, if a user has selected a map region of 500 into 500, right? He has zoomed out, so his area is 500 into 500. So you have to basically now do the calculation and aggregation, right? So do
Right.
you have some
So
ideas how will you do that?
yes. So in that case, like, if you think about a quad tree,
Mm-hmm.
the quad tree has four children, and assuming that for a particular region, so let's take a very simplistic example wherein we have a root and that root has four children, correct? So those
Mm-hmm.
four children are 10 cross 10, and you are saying when a user zooms out and goes to that particular parent, right?
Mm-hmm.
So when it goes to that particular parent, it basically checks like, okay, it has these four children, and out of these four children, these are the top five leaders, correct? So there will be 20 leaders. So from those 20 leaders, it selects the top five, and that will be the top five for that particular parent, correct?
Mm-hmm. Okay.
Yeah, that is how I mean I prefer calculating the leaderboard in case the user zooms out.
Okay. 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 Um, so so like the information that you're storing in the leaderboard is at the granularity of 10 cross 10, right? And now if
Mhm.
a user selects a region, you will be basically finding what are those regions that you have in your leaderboard, and then you will be getting that data and aggregating that data, right?
Right.
So, uh, like, what about if a user has selected a larger region, right? Let's say if he has selected like a much bigger region, and then your queries could be very slow, right? Because your query has to fan out to so many shards because the data would be spread out in so many shards. So what do you think about that? How can we improve that latency?
Sorry, I didn't get this one completely. So you are saying now all of my users, they are sitting at the top level, right? Or at the top level of that particular quad tree. So in that case, I need to bubble
Users
up
could
all the
user
leaderboards from the leaves to the root.
So user is sitting in some location, but he's viewing the map of a much bigger region. Like
Mhm.
the area of that region is very big, right? So
Right.
now you have to collect that much data points from your database and then find me the top in that region, right?
Right, but then you do not calculate it every time. Why do I say that? Because suppose you calculate it once and then you just treat it like a heap. So what happens in a heap is in case the data changes, suppose it is a max heap. So when
Mhm.
the data changes in one of the nodes, kind of a children or the leaf, so automatically it bubbles up to that tree, right? Sorry, of that heap. So similarly, we need not calculate everything again and again. All the data, like if there is, a leader change in the leaderboard at a particular child, then, it will automatically reflected in its parents. So this
Yeah.
thing, like, right? So we do not do it on demand. Like, when the user zooms out, at that time that he will be seeing the leaderboard of that bigger region, but then all the calculations are done before during the right time. And when I say during the right time, like when I update a particular leaderboard, I make sure that this new leader he flows even up to the parents, so that the
Mhm.
reads are much fast compared to the writes, because
Okay.
anyhow the leaderboard writes are happening asynchronously.
Mhm. And then, so whatever this data structure is, which is some sort of heap to keep these maximum scores. So this data structure uh, basically will not be able to fit in a single machine, right?
I mean, we can do some calculations. So suppose, we said that we have 1 million users, right?
Mm-hmm.
So we have 1 million users. So if in this data structure, like what all fields we'll have a particular user ID and his score, correct?
Mm-hmm. Mm-hmm.
So assuming all of the users are playing, 1 million users are playing, so 8 bytes for a particular user ID, and again taking 8 bytes. So maximum 20 bytes for this information of one record saying that this is the particular user and this is his score. So 20
Mm-hmm.
bytes into 1 million, I mean that just comes out to be 20 megabytes, right?
And no, but region, you also need to store region, that in which
Right. So
region
I mean
those
region
fields
will
were
be
done.
much less compared to 1 million. I mean if you even take the whole US, so how
Mm-hmm.
many regions like do you anticipate there will be? I mean, 100 million regions.
Mm-hmm. Okay.
So even
So
if you have 100 million, so 20 into 100 million.
mm-hmm.
So that will be 2000. So that will be just 2 GBs. So
Okay.
that can easily reside on the machine.
So you are saying this, and okay, and then okay, I got it. So it's a in-memory data structure which is in a machine, and you get this scores from that. Okay.
Yeah, I mean, we will have to keep it in memory, to keep it because our system is kind of, almost a near real time.
Mm-hmm. Okay.
Yeah.
Okay, that sounds good. And I think yeah, like uh, yeah, basically I had a good understanding of what you're trying to build. Uh, so yeah, I'm just leaving it to you for last 5 minutes. If you have to just wrap it up or just want to share any other thoughts or ideas you have, go ahead, and then we can just wrap it.
Sure. So I mean, like, we have talked about all the caches, the queues, and then how do we make our system resilient? The last thing I wanted to cover was, how do we, like, we need to even enable the logging and monitoring
Mm-hmm.
because, I mean, in case of production issues, we need to see what went wrong and where, like, which microservice was down and things like that.
Mm-hmm.
So, for that, I think Grafana kind of a dashboard, like, we need to build that to make sure that, we have a clear picture of how our nodes are working and to do further analytics that the data coming from which region, like users are interested in which particular map, like
Mm-hmm.
why a lot of users are going into a particular map. So all of that data we can ingest, say in Hadoop, and use MapReduce over that to perform some analytics. Moreover, Grafana will be useful to see the load of the spike, load spike of the user, that if a lot of users are coming into our application, at what particular time they are coming in, or like from which geography they are logging in,
Mm-hmm.
right? And then logging, I'll say that we it's always better to introduce two levels of logging. One will be in the info mode and another one in the debug mode, so that tomorrow if anything goes wrong and we are not able to find out what or where it is going, so we can
Mm-hmm.
enable the debug mode, which will have a more detailed logs to see,
Mm-hmm.
to find the root cause analysis.
Mm-hmm.
uh, yeah, so that is for the logging and monitoring purposes.
Yeah, that's good.
Yeah, that's it. Yeah, I think like that's fine.
Okay, yeah, that's yeah, okay, that sounds good. Yeah, I think that's all I wanted to talk to you about in this. So we can wrap it up, and yes, so we can now move to the next phase of this interview, where, as Asim mentioned, so we can just discuss how you felt, and then if people have any observations and feedback they can provide, and then finally I can provide my inputs.
Sure. So I'll start with I mean, the problem statement was something new to me, like to design a Pokemon core system. So I've never heard of this thing, frankly speaking. But then, when like I was discussing about the requirements that there is a particular map and the Pokemons are present, so it seemed like familiar that instead of Pokemons, like if there are coins, like I would have played it somewhere, like so it wasn't that kind of a new system design, but then yes, I could visualize it using the maps and how the user collects it, and then
Mhm.
I could figure out that we need to fan out the leaderboard and things like that.
Mhm.
So I mean, it was a good system design. I mean, a lot of concepts were involved, And I mean, initially I had little apprehensions, like, I was a little confused, but then while we were talking, uh, I mean, I feel pretty confident with the design.
Okay, that's good. Yeah, no, yeah, it was good. Okay, that sounds good. I now leave the floor open to audience if they have any feedback for Mindpixel. Please go ahead.
If I may, and say some things about what I observed with Mindpixel's approach to this problem. Is it okay to share my?
Yes, please go ahead.
Yeah. So it was good discussion overall, but I think Mindpixel went the first thing into a low-level design first. I mean, typically what we see in high system design interviews are go from top down, right? But he went to the database design first. That I felt a little different. And the other things I noted down is a normal. So when I forgot the interviewer's name, sorry, Abhishek, right? Yeah, when Abhishek,
Yeah, Abhishek.
when Abhishek was saying that there was one situation, like he said that he does not seem the database to handle this. Mindpixel could have asked, probed more about why he thought so, to understand his perspective before answering it. But he right away said no, and then he proceeded to give his explanation. He didn't really care to ask about his perspective in detail. That could improve, because it's very important to, when we interview, it's very important to understand the other person's perspective also before we, of course, we should have our own opinion, but we should also try to understand their perspective and why they say it does not work the way we think it is. That could be improved.
Yeah, I agree.
Yeah, that's it. Thank you.
Thank you. Is there anyone else? Okay, then yeah, let me give my feedback, and yeah, I'm just giving it as I have observed, and yeah, I've not taken time basically, otherwise I would have taken some time if other people were also giving feedback. So okay, so before giving the feedback, right, I just first want to discuss about what happens in a system design interview. So basically, when given a problem like this, you in your mind you get a lot of ideas, right? And your mind is randomly thinking about this idea and this idea, and it's sometimes hard to organize your mind and go in a particular direction. Whereas when we are doing a programming question, like we have some organization in our mind, but in a system design, because there are so many things and it's our multi years of experience and we want to use that and that, and so our mind is basically randomly scanning through a lot of areas in our memory. And so that's why I feel that it is very normal that like, and I feel that we should not block our mind. So whatever ideas which are coming to our mind, basically we should write it somewhere, or maybe we should say, yeah, this I'm thinking, but let's discuss this, right? So which happens, and that's why I like, according to me as an interviewer, I feel it is okay if interviewer he has some ideas, he shared a little bit about them, and then he came back on track and did the sequential way of how maybe he should organize his system in design interview, right? So that being said, now moving to the observations that I felt. So first of all, Mindpixel, you did really great job. Besides this problem that we have in a system design interview of randomness in our mind, but still I felt according to that it was very organized. And yeah, like you gathered the requirements well, and basically how you approached it, it was all good. Uh, and then, so when you were doing requirement and APIs, like I felt everything was great up till that point. Then we came to data modeling. So again, in data modeling, I felt that, and maybe I'm maybe not clear up till now, but basically how we store this information of what regions the user has collected the Pokemons. I felt like there was little lack of information there that was not very clear to me, but I understand that because at like at this time you were still figuring it out, so it's fine, it was not clear, but slowly as we progressed in the interview we slowly figured it out, right? And then you basically drew the high level uh, diagram, which was very great, right? I mean, it had basically API gateway, all the basically microservices for each of their independent tasks, the database, how the database would be, and how the right request will be made to the database, right? So very good, right? Yeah. Um, so all this is good. Overall, I would say that it was very good interview, but like just some things which I felt that uh, you can improve. And uh, so one thing is, so the discussion that you had about the caching, snapshot, write ahead log, right? I felt so there you were throwing so many points, but see, basically that task is done by a database. If you're saying you are using a database will maintain your write ahead log. Database and most database have some kind of caching and all. So basically you were like I was felt you were explaining me that how databases are working, right? Because basically this is how databases work, that they have basically LSN trees or B trees where they store the information in memory, but they also have a write ahead log. And with time they flush that into the B trees or whatever, right? So you were building that similar kind of a structure, which could have been easily abstracted out because you said you are using a database, right? So database is doing that thing for you.
Okay.
And I mean, caching, yeah, you can add a layer of caching, but that snapshot and all that thing was what a database does, right? Then, secondly, I still felt that we did not have very clear discussion on the leadership board part. And maybe, I don't know, maybe I'm not very sure, maybe I was not very clear or something, but overall, so basically in my mind, this and basically system design has like a lot of right ways to do things, but in my mind, I still could not get a very clear idea of how the calculations would be done. And I was not looking at knowing that special data structure for this geo and all, right? I was not looking at that, but uh, I was basically wanting to know that in a particular region, if a user has selected a region, so that region is comprised of many small regions, right? So let's say if he's selecting a map of 1000 into 1000, right? It will be composed of smaller rectangles. So how that information is stored, how that information is aggregated, and all those things. But no, actually, I'm a little bit incorrect here. I think in the end, you talked about that how in memory you will store that in a B tree, in a heap kind of a data structure, right? And that will be updated. So yeah, okay, so that was good, I think. Yeah, so overall, I felt, yeah, that this interview was good and you did really good. Yeah.
Cool. Thanks, Abhishek, for the feedback.
Is there anyone else that has to add anything to this thing? Okay, so now, as Asim mentioned, the last part, which is any questions related to the technical design of this. So I see in the chat some people have some data structures and all. Do anybody want to talk about it, or now go into the technical discussion of how this system should be made? Because in a system design, there are a lot of approaches. So does anyone else has any other approach that they want to discuss?
Can you talk about the aggregated part? Like, let's say user select a bigger region, then how you aggregate the data, because kind of like you have to scatter and gathering, right? Because different region in different area. And now you have to aggregate, and how you can like make it fast.
Yeah, okay. So let me talk about that. The design, one of the designs that I was thinking, which is similar to what Mindpixel has, but like I just want to explain how I think about it. So basically, when we're building systems like this, generally you have two kind of data systems, and we will see this common theme across a lot of systems. So first you have your source of truth, and then you build a derived data system out of that source of truth, which is read efficient for some reads that you want to perform, right? So basically here, the user DB, that is the source of truth, right? Because when the scores that are there for the user that lives in that database. So that source of truth database, they have to be always updated synchronously so that we never lose that information, right? So, I mean, there, if you talked about having a queue, I will not have a queue in this system because I want that system to be consistent, because if a user has got a Pokemon, basically we should shard this information. So this database should be sharded by user ID. And then when a user gets a Pokemon, we go to his shard and then we update his score, right? And it should happen synchronously, because when he's viewing his own score, he should get up-to-date information. Otherwise, he'll be confused. He had 500 score and now he collected one more Pokemon. If his score is not reflecting, like he will say this app is not functioning fine, right? So that should be updated synchronously. We should not have a queue here, because if we will have a queue here, then we are updating this information asynchronously, which will make our system feel wrong, right? So now,
sorry to interrupt, Abhishek. I have a question here. So I felt from the question that the Pokemon you collect is valid only on that region. Is that understanding correct?
yes.
Like
Yes,
if I collect some Pokemons in Chicago, it's valid only in Chicago, which means should we not be sharding based on regions instead of user?
So for what? Like, but so the thing is, I'm talking about when we're updating the source of truth data. So the source of truth here is user and his score, right? So
Okay.
so when you are, so see, basically we want to see that what should be the primary key of the database, so that whenever we want to update that value, we can use that primary key and directly go to that shard and that row key and update that value, right? So when a user is collecting a Pokemon, the main primary key is his user ID, right? So in the database, we need to find where is that user's information in the user ID row, and there we will be updating his score, and then we will also like add the latitude, longitude, and update his score, right? So that's why I think that this information can be sharded by the user ID. But the other system, so the derived data system, which will give me the top K Pokemons in a particular region, that information I feel should be sharded, as you're saying, by the region, because there we are our reads are based on the region, right? That in this particular region, what are the top K? So there our database lookups are based on the region. So I will say that
Got it.
all latitude, longitude in this area give me top K. And so, yeah, so this is the idea. So you have your source of truth data asynchronously. You are building a derived data system which is read efficient for this kind of query. So you are writing some worker jobs or something, which is, and there you can have a queue or something, right? So as you update your source of truth data, you also put it in a queue that now you want to update this information in your basically other database, which is storing the top K for that region. And then that database is updated. So now if you want to get top K for that region, you look up in that database, because if you go to user database, like your query has to span across all the entire database, right? So this is the main idea behind this system. That is the crux of the system. So first, like I would explain to someone like this. And I feel like if we have this understanding, we can build a lot of data systems. We have a source of truth, and then you build a derived data system out of it, which is asynchronous, which is good for read, right? Now coming to the second point, which is aggregates, right? So like how I was thinking about it, and I don't know if that's the great approach, because frankly, I don't know any data structure for this geo kind of data. And I know there are some data structures which have been built specifically for this, so we can optimally do those things. But like I was thinking that having this pre-aggregates, right? So basically for that smaller maps region, so let's say I'm having 100 into 100 maps. So I'm dividing a map into smaller pieces, smaller rectangle, that entire map into smaller rectangle. And I'm storing the pre-aggregates, that what are the top K users in that map, right? And so now once I have that pre-aggregated stored, so this pre-aggregated is being calculated asynchronously, right? Now, if a user selects a map region, then I will basically find out that, so that map region will be composed of some smaller boxes, right? So I will see for what smaller regions I already have a pre-aggregate, right? And I will have that pre-aggregate, I will do that summation and all. So with the pre-aggregator, I will save a lot of time in basically at that moment in calculating the information. So I had this basic idea in mind, but I believe Mindpixel had even, so he knew about some data structure, which I'm not sure what the quadry data structure is, but yeah, so some data structure which has that pre-aggregated information stored somewhere, so that you could. But I felt that having that data structure in memory could be a problem, because over time when we expand to multiple regions, it could not fit in memory. So basically, yeah, we could store these pre-aggregate in a database also. Plus, we could also build out some in-memory components out of it and use a combination of both to get the top K.
Okay, so let's say a small, let's say a small atomic region, right? And then now you update the leader score. Now you have new leader score in that region, and are you gonna propagate that leader score to the higher region and all the way to the top? And how you do that? Are you sending the message to your queue, or where you send the data?
So yeah, that's a great point. So basically, and so once we have decided that at what granularity we are storing these pre-aggregates, so then once a score is updated in a particular region, we have to update all the data storage systems that has that pre-aggregate. So let's say if I'm basically storing a pre-aggregate for Bellevue, right? So no, basically let's say my score was updated for a user in Bellevue. Then if I have a pre-aggregate for Washington, if I have a pre-aggregate for United States, I have to update all those things. So those could be our asynchronous jobs that could be running, that could be basically calculating these pre-aggregates and update them asynchronously. But I believe if there are some better data structures which have been actually built for it. Yeah, I think so. That's what I want to hear from you guys, basically, because I saw in the chat that some people were talking about how Uber uses it. So I would be interested to know that, like, how those are built. Okay. Yeah, I think, yeah, I know, yeah, I'm looking at the chat and I know those data structures are complex. So yeah, I think none of us have very good idea about what those data structures are. So yeah, I think yeah, that's fine. And even I also don't know about it. So yeah, but basically, does anyone has any questions on this pre-aggregate kind of information, asynchronously building pre-aggregates and then updating those and having a source of truth data which is updated synchronously and then a queue of updating pre-aggregates? Are there any questions over there? Mindpixel, do you have any questions specifically?
No, I think I'm good.
Okay.
I just have one question. It is just generic. So, as per the design we have today, so that the latitude or the geographical location we have stored into database, right? Is that normally the industry follow, or is it they use some other technique?
Yeah, I don't know about that.
Okay. Yeah. And just one more. The interview, I think I can see there are so many user kind of profiling, user credential, user login, right? So normally in interview, do we need to discuss about what kind of authentication, how we are securing our system? Do we need to discuss that as well, or is it just a?
Yeah, so, and that's a good question. So see, like in a system design, there are so many things you can touch upon, right? Like we can go deeper in the authentication mechanisms. There are so many authentication mechanisms, right? And creating user profile and all. And so, like, I feel like, and as an interviewer, he's not wrong if he's focusing on something. So I feel as an interviewer, he has to give hints that what he's more interested in so that he gets enough time to discuss whatever he's interested in. So in my interview, I told him multiple times that I'm not interested in other components, mainly focused on the leadership board, right? So I think in this interview, he should have not talked much about authentication, and which he did well. He did not talk much about authentication and user profile, how to create that. But if an interviewer has not mentioned that, then probably, yeah, I mean, you can briefly talk about that in 15 to 20 seconds and see his response if he's more interested. Because I mean, it's also a very important discussion that how will you secure your APIs, right? Otherwise, someone can maybe DDoS your APIs and like leadership board, so your service will go down, right? So how will you secure those APIs and authentication and all those things? So we could definitely have a discussion on that.
Okay. So probably if it is an application is more like a financial oriented application, we should have think about more like security as well, right?
Yeah, that's a good point. If our application is something like financial, where security is very important, then yeah, definitely it's good to touch on those points and see how interviewer responds to them and if he's interested to hear more about them.
Okay. Yeah, thank you.
Hey, Abhishek, maybe a silly question. So this is the first time I'm hearing the word fanning out. What does that mean?
Yeah, no question is silly. Yeah, even I also learned it like just some time back. So basically, fan out means distributed query. So like your data is sharded on multiple machines, right? And so this aggregate value, so these tables, they don't live on one machine, they will be sharded on multiple machines. And now what you have to do is you have to go to all the shards. So you're fanning out, means you're going to all the shards, getting the information from all the shards, collecting. So let's say you are asking each shard that give me top five. So each shard will give you top five, and then you will, out of those, you will get overall top five and return it to the user. So fanning out is like doing a distributed query to all the shards and connecting the information, doing some processing, and then return it to the user.
Thank you, Abhishek.
So what kind of database is Cassandra? Is something it's used like that?
I don't have a great answer to that. Does anyone else want to answer? Because I have not actually used
Okay.
Cassandra database.
So I was reading about it. The leaderboard. It's a famous problem in the common gaming industry, right? So a lot of it point to Redis and the sorted set data structure. I don't know anything about it, but that's what Amazon, Microsoft referent architecture, all of them point to Redis.
Okay.
So I know you don't know fully about it, but whatever you know, can you share like what you have read about it and what are the ideas? Okay, I thank you for sharing the link.
So Abhishek, I'm still not clear about the problem statement. So when this user has these Pokemon, so like he or she collect in one region and move to the different location and collect in that region as well. So can that user be on two different leaderboard?
Yes, he can be on two, because in one city, the Pokemons that I have collected, so that will be basically stored as the data that in this city I collected these Pokemons. Now, if I move to a different city, my data still lives that in this city I collected these many Pokemons.
So when we have to show the leaderboard, so we don't need to care about whether user is still active in that region or not.
Yes, you're right. We don't need to worry about it. We just need to see that what are the top users, even if right now he's not in that region. That's fine.
And with that information, I'm still not able to actually make my mental model that how the pre-computed will help here, as as these regions are dynamic, right? So that region will be determined based on the user current location or whatever area user will select, right? So that could be that area is dynamic, that rectangle is floating.
Yes.
So how the pre calculation will help here?
Okay, so my point is that when a user is selecting a map on his mobile phone, right, we want to get the leadership score on that for that particular map, right? And now if we basically start fanning out and start aggregating all the latitude, longitudes are there in that map, then basically our latency will be very high, right? Because in that particular map region, there will be so many points, right? And there will be so much of data.
Do we need to worry about the points? We need to worry about the users in that area.
No, we don't need to again. So remember the first part is we don't need
Okay,
to
okay, got it. Yeah. So
worry
whatever
about,
point were in that area. Okay,
yes,
got it.
what the points are corrected. So that information we can do a pre-aggregation, right? And so we can do pre-aggregation on a smaller region basis. So a bigger region could be comprised of smaller regions, and we have the pre-aggregates for them. So then we just do the calculation and add the value rather than doing the calculation from scratch, basically going through the table and see what latitude longitudes are there in this region, then adding up the score for all the users, and then actually doing that calculation.
So you said that, I mean, pre-calculation for the points in that region, it could be possible that some of the points were not acquired with anyone.
Some of the points, yeah. So, okay. So how will that create problem?
We don't need to consider that in our leaderboard points.
Yes, we don't need to. So if some region they don't have any scores, so the
No,
values will be
they in that region there are scores, but those Pokemon were not acquired by anyone, any user.
Okay, so yeah, so that will not be the part of the calculation. Only the ones which, and if in a, so let's say you are selecting one map where no Pokemons were collected, so then the top 5 will be empty because there are no top users. Right? Am I missing something?
I'm not sure. I mean, I'm still afraid to say that. I mean, still not able to visualize
the
storage part.
Let me maybe open Paint and quickly share my screen and tell you what I'm thinking about. Maybe.
Yes, please.
And so then you can let me know. Share screen. Only participant can. So excuse me for my bad drawing, but let's say this is a big map, right? And so I'm saying, let's divide this map into smaller regions. And so let's say we have, and they will be of equal size, let's say. And we have, so this map is of, let's say we have already pre-aggregates for these small regions, and like this we have calculated for entire map, right? So now as a user, if I am selecting this map region, right, in my mobile app that show me the top K users in this, right? So what I'm saying is that I have these pre-aggregates. So if there is little inaccuracy, it's fine, but I can use this rectangle, and whatever rectangles are there in this entire box, I can use those pre-aggregates and then do the calculation. If I don't have these pre-aggregates, right, then basically I have to go to the entire database and see what all points are possible in this and then do the calculation. So this is my idea, that storing these pre-aggregates and then using them to compute the information when we need to compute.
So you are making an assumption that these small pre-computed area are atomic area, right? And these will be considered as a whole in a particular region when you have to zoom out, right? You cannot split that further, like you
Yeah,
split
we
it
cannot
here.
split that further. So there could be little bit inaccuracies because,
okay,
I mean, I have collected that outer region also, right? Although that is not there in the map. So,
yeah, let's make that assumption. We cannot split these atomic units of these region. Okay.
Yeah.
So now back to the Leon question, that I mean, when you have to cover the whole region, that whole complete US, then again you have to do the same thing for these tiny atomic region and aggregate that.
Yeah. Yes. Right. And yes, so exactly, that's a great question. So now if we are looking at big US region, then even these pre-aggregates are a lot of regions that we have to compute, right? So then the other point was that we can also have bigger pre-aggregates. So I can have a smaller pre-aggregate, and then I can have a bigger pre-aggregate that I'm storing this, like if you see this ping boxes, I'm also having pre-aggregates for this. So now if a user selects a bigger region, which so if now a user selects a bigger region, then basically we can use bigger pre-aggregates. If we have bigger pre-aggregates, we will use bigger, and then whatever smaller pre-aggregates we have, we'll use smaller pre-aggregates. And then also the point is, if a point is updated in this region, we have to update the smaller pre-aggregate also, and we have to update the bigger pre-aggregate also. And those things we can do asynchronously, because this leadership board is an asynchronous system, right? So even if the scores are not immediately visible, that what are the top key leaders, if there is some eventual consistency over here, that is fine. But our latencies should not be high, right? So when we are fetching that leadership board, it should not be getting stuck. If the information is a little bit stale, that I think would be okay with the user.
So here my question is, as initially we make that strong assumption that we cannot break these small atomic region, right? Now when we pre-calculate this bigger region, right, as it's a pre-calculate, and now now how that will help if user actually select some area in that it's some part from the one big region and some part from another big region, how that will help here, these pre-compute for the big region.
So this pre-compute for big region will help in this way, that whatever bigger pre-computes I have, I will use them, and then I will also have smaller pre-aggregates for these regions, right? So my calculations are now much lesser. So like this, I will have smaller pre-aggregates, and like I will also have a bigger pre-aggregates, right? So I will see that bigger pre-aggregate is out of bounds. So whatever smaller pre-aggregates I can collect, I will collect the information and aggregate those values.
I mean, I do understand your thinking, and theoretically it looks like, I mean, yeah, it's doable, but I don't know, I mean, how practical it's feasible to implement that part easily.
Yeah, no,
I got your idea. That's like you have the bigger region, and that bigger region, inside that bigger region, let's say there is sub region. So take that as a whole, and then to complete fill that big region, take some small region with that big region.
Yeah, you are actually totally right. Even I also don't fully understand how it will happen, because basically, given this latitude longitude box, how do we actually find what will be the boxes inside it, right? Although we have the pre-computes, but what are the boxes that will be inside it? That piece of calculation will also be a little complex, and I feel that will need knowledge about this latitude, longitude, how to find nearby and all those things. So even, yeah, I don't have a very good clear idea of how it will be done. I'm just giving a like brief overall high level idea, but low level, even I also don't know that what's the right way to deal with these coordinates.
I'll think about that. I think what Mindpixel is that, I mean, like some sort of a quad tree. So still, I'm not sure, but I think that may help here if we actually have these dynamic kind of box and combine them.
Yeah, no, yeah, you're right. If that special data structure is there for these to store this kind of information, those special data structures, because they're built for this kind of usage, so they will be better. That basically that quad tree, it stores that granular information also, and it propagates the higher aggregate value at the top also, so that you can use them.
Yeah, so I think the way he was talking about the quad tree was a great one. But also in the quad tree, we still have to do some sort of like a segment tree way when we want to query and when there are overlaps, right? So there might be some overhead involved, but I think that will be still much better way of doing it. Yeah, this was a very good interview. Yeah, Mindpixel did a great job. Abhishek, you also. And the problem was also very different one, very nice one. Yep.
Yeah,
The
that
problem was really good. Yeah.
Yeah, it was
yeah.
very good.
So one quick question to the Mindpixel. So
Yeah.
So Mindpixel, I didn't follow you that when you were talking about the WebSocket and you talk about the shard based on the user. I mean these connections. So I did not quite follow you that what do you mean by that, and then you said that based on the region, and then you talk about the sorting that with the prefix or suffix, some suffix. So I didn't follow you in terms of the connection. I know these concept in terms of the database, how you store that information, but
So,
could you
what
elaborate more that what was your idea here?
yeah, what I wanted to communicate was like, we are maintaining the WebSockets, right? So
Mm-hmm.
now when the user sends in the request for creating that WebSocket connection, like we have two data points basically. One is the user ID, that this is the particular user, and then the region ID, which he has selected, correct? So either I maintain the WebSocket connection based on that particular user ID or based on the region he has selected. So I was just discussing the pros and cons that, how we keep the users, which machine has what all users, how do we maintain that based on the user ID or based on the region ID, correct? Like how do we group the WebSockets in a particular machine? If we group it based on the user ID, so it will be all random, correct? So I was just trying to show that in case we need to
So,
fan out.
so generally these TCP connections actually based on your hardware, how much your hardware can support.
Right. So I think the maximum limit, uh, if I'm not wrong, but then, WhatsApp or something like that, they have reached to around, I think 200K, but then the initial limit is around 50K max connections, which we can maintain per node, right?
Mm-hmm.
So, this is not about how many connections we can maintain, but then this was more about since we want to fan out a lot of information like the leaderboard, and then in case we want, it is a real time gaming thing wherein we want to, fan out the movement of each player. So I wanted to, not to send that information to a lot of nodes, just to a single node. So that's why I wanted to keep all the users of a particular region, their WebSockets to connections to be maintained to the same node. So this
But
was,
yeah, sorry, go ahead, please.
yeah. So this was my point of view. That's why I was discussing the pros and cons, like whether you maintain the WebSocket connections in a particular node based on the user ID or based on the region ID which a particular user has selected. So I said that if you maintain it based on the user ID, so then for a particular region, suppose we have 10 users and all those 10 users are distributed on different nodes, then you have to fan out the information about that particular region or the map to those different 10 nodes. Had it been we store the WebSocket connections based on the region ID, so then I need not fan it out to different nodes. All the users of that particular region are residing on that same node, correct?
How would you distribute a WebSocket based on user ID? Who is going to do that? You will need another component for that. TCP cannot do that.
So go ahead.
So when the user, he connects to our system at that time, he will be selecting a particular map, right? So first upon you log in into the system and then you select a particular map, right?
Which map? Who? I mean, I didn't get that. How you just get a WebSocket, domain